Assalamu alaikum everyone. This is lecture 15 for CS116 Object Oriented Programming. In last two lectures, we had been discussing multiple inheritance. We discussed the syntax, we discussed the search order, which is called method resolution order, and then we saw the usage of most common usage of multiple inheritance, which is mixed in classes. In today's session, we'll discuss association. This is where we ended our last lecture. We were discussing that sometimes multiple inheritance may result in too much complication. So an alternate to inheritance is association. Like instead of inheriting from a class, you can make that class part of another class. So we'll discuss association today. There are two types of association. If we recall from lecture 4, aggregation and composition, we'll recall these and we'll see how we code for these two types. And in the end, we'll revisit this LEBG rule. I hope you remember this from last semester. Firstly, let's recall from lecture 4. We discussed this association as a relationship between two classes without any rules. It can further be classified into composition and aggregation. Let's suppose, and what happens in composition and aggregation? We embed one class into another. That means we make one class part of another class. So let's call one class container class, and the other class which we are defining within the container, let's call it the content class. So in composition, what happens if you delete the container object, the content object is also deleted, right? Whereas in aggregation, if you delete the container object, the content object still lives. Or in other words, we can say in composition, the embedded object cannot live meaningfully without the container object. Whereas in aggregation, both are separate entities. We are making one entity part of another entity, but they both can exist independently as well. So we can say aggregation is a weaker form of composition. Now, like association is the weakest, then we come to aggregation because association is without any rules, then we come to aggregation, and then composition is the strongest relationship. In last lecture, I showed you how you can make one class part of another class. But if you think about it, we had been using this association relationship since the very beginning. We had been using this unknowingly. Like we all know that integer, float, string, list, etc., they all are classes by themselves. So whenever you define an object of any of these built-in types within your class, that means you are embedding one class into your own class, right? So that means that you are creating an association relationship. So what's new in today's lecture? We'll see these relationship like from implementation point of view, like how can you classify these definitions or embedding of one class into another as aggregation or composition or a simple association. So we'll see examples for this, and we'll see what happens at the back end when you try to define such relationships. Okay, I'll explain this backwards. Like first, I'll give you example for composition, then I'll move on to aggregation, and then I'll move on to association. So in this example, what I'm doing, I'm defining a simple class called class B. This is the initiator method for class B, and there is nothing difficult about it. This initiator method will be passed this value var, and this var will be assigned to variable b or varb, and this variable b is an instance attribute of class B because I am accessing it through self.operator. Now I'm defining another class, class A. This is the initiator method for class A. Here user will pass two values, x and y. For x, I am defining an instance attribute for class A which is called variable A. This x will be assigned to variable A. And for y, what I am doing, I am defining another instance attribute here, instance B, instb. But this instance B has been initiated to an object of class B type, right? So this B, and we are writing that y within those round brackets. That means that I am instantiating an object of class B type with value y. and that instantiated object will be linked to this instance object of class A, which is called instance B, right? Now, the thing that you should note here is that instance B is instantiated inside class A. Instance B is of class B type, and I'm instantiating it within class B. This is composition. That means that the object lies within another object, like class B's object lies within class A, and it will live as long as class A lives. Let me show you, let me prove this to you through some code. Now, let's suppose in main code, I instantiate an object of class A type. You see, class A's initiator takes two values. So I am passing two values, one string containing R and another integer value 5. So what will happen at the back end? There are two classes. That means two class blueprints will be created. This is the blueprint for class B. There is only one method in this class. There is no class attribute. Similarly, for class A, there is no class attribute and there is only one method, which is the initiator method or the init method, right? And when you instantiate this object AA, a separate namespace will be created for A. Now, this namespace will contain all the instance attributes. So variable A is an instance attribute, and this is the second instance attribute, instb. Now, this instb is initializing an object of class by type, and since that has been initialized within the namespace of A, so you see I have shown that namespace within A's namespace. So this is composition. That means that class B's object is part of class A's object and it lies within class A. Okay, moreover, we are initializing these values R and 5. These are two separate objects. These has been defined in the main program. And when you run these initiator, I'm not going into detail how those initiators are run. I hope you will be able to figure that out. But when these initiators are run, variable A will point to R, and instance B or variable B of instance B will point to value 5, right? Now, if I run this statement here, what I'm trying to access variable A from object AA. So let's see, in the namespace of AA, there is variable A and it is pointing to an object R. So R should be printed. And here's the output, right? Similarly, the second statement here, I'm trying to access variable B, but variable B is part of instance B, right? Instance B is a B class type object, and variable B is part of this instance B. So there is a double indirection. I'll access instance B through AA, through object AA, and then from instance B, because instance B is of class B type, I'll access its inner variable B. So you see, this is pointing to 5. So 5 should be printed. And here it is. Okay, now if I run this statement, del AA, where del is an operator which will delete this object AA, what will happen? This particular namespace will be deleted. Now, this is the namespace for A. When it will be deleted, then variable A will be deleted and instance B will also be deleted. And the second namespace for object B was also defined within namespace of AA. So that will also be gone, right? Now, as far as R and 5 are concerned, they'll be left in memory. But without any reference count, because variable A is gone and variable B is gone. So they'll be cleaned up later by garbage collector, right? But our statement will remove this particular namespace AA. So let's suppose after deleting this, I try to access variable A through AA. This statement will produce error, right? Similarly, if I try to access variable B, I cannot access that variable B without accessing instance B, and instance B is accessed through AA. So again, this statement will also produce error. That means variable B is also inaccessible now. Now let's implement the same example through aggregation, or let's change it a little bit to show you how aggregation works. In this example, again, I'm defining their class B the same way, exactly the same way. I'm passing a variable var that will be assigned to the instance variable varb while instantiating an object of class B type. So there is no change in this. There is a small change in class A. In initiator function, user will pass two values x and y. X will be assigned to variable A and y will be assigned to instance B. So there are two instance variables, variable A and instance B. But the difference here as compared to the last implementation is that here for instance B, we are not instantiating an object of class B type. Rather, I am assigning a direct value y to it. And here I am expecting that this y will be of class B type. Like user passes an object of class B type here. So the new thing here is that we are not instantiating that object within class A, but we are passing it from outside, right? So in main program, what I'll do, I'll first instantiate an object of class B type. BB is that object, and it will instantiate variable B to value 5. This 5 will be passed to initiator function of class B, and that will be assigned to variable B. So that means BB is an object of class B type, which has been initialized in the main program, right? So this is initialized outside of class A. So here is where the difference lies. In composition, we instantiated class B type variable within class A, and here we are instantiating it outside the class. So now let's see what happens at the backend. When you execute this statement, this namespace for class B will be created, and it contains only one method in it. There is no class attribute, and BB will class A's name is, let's create it. It doesn't matter where we created. Class namespace for class A will also be created. It will also contain only one initiator method, and there won't be any class variables. But this statement BB is equals to B5, it will create a namespace for BB, and that namespace will contain only one variable B, and 5 will be an independent object, and variable B will be pointing towards this, right? Now let me instantiate another variable, again AA, of class A type, and now here I am passing two values, R, which is a string type variable, and BB, which is the object which we just instantiated in the last statement, and this BB is of class B type. So what will happen at backend? Now this namespace will be created, AAs, and variable A and instance B will be two instance variable residing within this AA's namespace. R will be an independent object. Variable A will be pointing towards it, and this instance B will point towards BB, because we are passing this BB variable to it, and BB has already been defined in the previous statement. So this instance B will be linked to this namespace, right? Now if I try to print this variable AA dot variable A, that means we are trying to print that variable A within AA's namespace. So R should be printed, and here it is. Similarly, if I try to print this variable B, now this variable B resides within BB's namespace, so it can be accessed in two ways. You can directly access it to BB, and since we are linking it to instance B of class A, it can also be accessed through that instance B. So first I'll show you, if you access it through AA's class, what will happen? AA dot instance B, and then instance B is pointing towards BB. That means in order to access variable B, you will have to use double indirection. So this will print 5. And the second way of accessing the same variable is you can access it directly through BB, like this statement. This should also print 5. That means instance B, B's variable B, and BB's variable B, they both are pointing to the same value, 5, 5. Now let's suppose if I delete this namespace AA, then this particular namespace will be deleted. R will be stranded after that, which will be cleaned up later by garbage collector, because once you delete AA, there won't be any reference to that object R. But to this other object, BB is still there. We have not deleted BB, so that second object still lives. And if you try to access variable A this will give error because that namespace has been deleted. But if you try to access variable b through AA, this will also give you error. But if you try to access variable b through that bb variable, then that is absolutely fine because bb's namespace still exists. So this will print 5. Now let me show you how association works. I'll alter the same example again. Here I'm defining this class B exactly the same way as we had been defining it in the last two examples. And there is a slight change in class A. I'm passing two values x and y to this initiator method. First value x will be assigned to this instance variable a1, and y will be assigned to second instance variable a2. Now see, the difference here is, as compared to the last implementation, is that I'm not enforcing that variable a2 should be of class B type. It could be anything, like y could be anything. It could be an integer, it could be a string, float, or it could be a value of class B type. It could be anything. So whatever it is, it will be assigned to variable a2. Okay. Now if I instantiate an object of class B type, bb is that object. I'm instantiating this object bb with value 5. That means 5 will be assigned to variable b. So what will happen at backend? Two namespace exist for two classes. This space for blueprint for class B and blueprint for class A. And this new statement bb is equals to b5 will define a separate namespace for bb with this only instance variable b. And now this variable b should point to 5. So 5 is an independent integer type object which was defined in main, and variable b now points to it after initialization. Now in the second statement, what I am doing here, I am instantiating another object of class AA type, and you note here the difference is in the parameters. The first parameter is the same, it is a string type value which will be linked to x and then later assigned to variable a1. And for second parameter, in the last example we had been passing bb here. That means whole object of class B type was passed to class A, and it was made part of that class A, or you can say we embedded that object in class A. But here I am not passing that whole value, but I am accessing part of bb, which is variable b, which itself is an integer, and I'm just passing it to class A. So what will happen at the back end? This namespace will be created. It will contain two instance attributes, variable a1 and a2. R is another object. A1 will point to R after instantiation, and A2 will point to bb dot variable b's value, which is 5. So here it is, right? So now you see here that I'm not making bb part of class A. I'm not passing it to class A, or I'm not instantiating it within class A, but there is some relationship between the two classes. You cannot call it aggregation, you cannot call it composition. So it is a simple relationship, and it is not inheritance either. So you just call it association. Now let's try printing some values. First, I'm printing these two values, variable a and variable a1 and variable a2, and there is nothing difficult about it. Variable a1 points to R and variable a2 points to 5. So these two values will be printed. Okay. And after that, I'm printing a second statement where I'm trying to access this variable b through bb. So this is also pointing to that same object 5. So this should also print 5, right? Now if I delete this object a, which namespace will be deleted? This one. So namespace of bb still exists, 5 still exists, R still exists with no reference to it, so it will be later removed by garbage collector, but 5 and bb, they exist normally. So if I try to access now variable a1 and a2, this will obviously give error because that namespace no longer exists. But if I try to access variable b from bb's namespace, that is absolutely fine, and that should print 5. Right? So I hope the difference is clear between association, composition, and aggregation. The only difference is in where you instantiate an object, within one class, or you instantiate it outside the class and pass it as a parameter to that class. That makes all the difference, right? Now let me show you one more way for defining composition. Last time when we were doing composition, what we did, we defined class B as a separate class, and then we defined another class, class A, and we instantiated an instance of class B type within class A. The alternate way is that you can define that class B within class A as well. So in this example, I will not define class B first. I'll define class A, and within class A, I am defining class B. So here class B's definition is also part of class A. And then I'm repeating the code that I wrote for class A. The initiator function, 2 values will be passed, and you see variable A will be instantiated to X, and instance B will be initiated to an instance of class B type. But the only difference is here is that class B's definition also lies within the same blueprint, not outside class A. So this is the difference from the last approach. In the last approach, class B was defined outside. First, let me complete this example, and then I'll show what advantage does it give, or what difference does it make if you define class B this way. Now let's run some test code. Okay, now if we see the blueprints here, this is class A's blueprint. It will contain only one initiator method, no class attribute, and class B's blueprint will be created within this blueprint of A, right? That means class B's blueprint is part of class A's blueprint, right? Now if I execute this statement here, I am instantiating an object of class A type. So I am defining two objects, R and 5, right? And I'm passing these two objects to this class A's initiator. So what will happen, this R will be assigned to X and X will be assigned to variable A. So namespace for AA will be created, and this will contain two instance attributes, variable A and instance B. Variable A will be linked to R because I'm passing it as a parameter. And for instance B, what I am doing, I am instantiating an object of class B type. So that means now a namespace for an object of class B type will be created within namespace AA. This is the same thing as it happened last time. And this value will be linked to 5 because I am passing 5 in place of Y, and instance B will point to it. So this is the same thing. The only difference is that the blueprint B lies within the blueprint of A. So now if I try printing AA dot variable A, that means it will print R. Here it is. And if I try access variable B through AA, then there will be double indirection. AA will access instance B, and then instance B is of class B type. So it will intern access variable B. In any case, it will point to 5. So it prints 5. Okay. Now let me show you one more thing here. Let's define an object of class BB type, or let's try to define this object of class BB class B type. Now the problem here is that class B, we defined this class B within class A. So if you do this change or make this change, this won't allow you to access class B even for definition without accessing class A. Like you cannot access class B independently without using any instance of class A. So if you try to define an instance of class B separately, this statement will cause error. Okay. So if you want to define an instance of class B type, what you'll have to do, you'll have to access it through some either through some object of class A type, or you can use direct this class name dot operator A dot B. So you can access that internal class B through A dot B, or you can also access it through AA. So I'm not showing that example. You can try that by yourself. So you can do this, and this is absolutely permissible. Now BB, if you try to access BB dot variable B, so this will again print. What should it print? It should print 8 because we instantiated it to that new value 8. So here it is printing 8, right? So the only difference this alternate way of composition makes is that here, since you are embedding class definition within another class along with instantiation as well, so you won't be able to even instantiate any object of class B independently. Like in last case you could do that, but here you cannot do that. Okay, I'll cover more examples on association next week, inshallah. Right now, I want you to appreciate one more concept, a subtle but important one, the LEGB rule. We have already covered this or discussed this during last semester, but there we had global namespace and the namespace created by functions, and then we had nested functions. But now we have classes as well. So we are placing or defining class codes also in our program. So let's see how LEGB rule works with classes. Let's recall the LEGB rule first, which we studied during last semester. Let me show you a quick example to help you recall it. Here I am defining a variable, global variable x in my main program, and I am assigning it a string called global. And then I am defining a function, and inside this function I am assigning another variable x, and I'm assigning it value enclosing. Now x global is defined in the global namespace, and this x is equals to enclosing is defined in function 1's namespace. Now I define a nested function, function 2, and inside this function I define another x and I assign it a value local. Now you see, up till now I have created 3 namespaces. One, the global one, where that global x will be defined, then a namespace for function 1 where this enclosing x will be defined, and then a separate namespace for function 2 where this x is equals to local will be defined, right? Now I am printing this value x, and I'm calling this function from function 1, and I'm calling function 1 from my main program. So what will be the output of this code? First x will be assigned that value global, then function 1 will be called. When function 1 is called, another x is defined in function 1's namespace, and that is assigned that value enclosing, and then function 2 will be called. And when function 2 is called, then a separate namespace is created where x is equals to local, and then it prints x. So this x will be picked up from the namespace of function 2. So local should be printed, and here it is, right? Now here I repeat this code. I've just made one change, this highlighted one. I commented out this statement, x is equals to local. Now when this statement will be executed, print x, it will not find any x in function 2's namespace. So it will access the E namespace, that is the enclosing namespace. E stands for enclosing in LEGB. So I'm expecting enclosing to be printed, and here it is. And a third variation is this one. Here I have commented out both x in function 2 and x in function 1. So when print x will look for x, it will first search it in functions 2 namespace where it won't find it. Then it will search it in the enclosing namespace of function 1. It's neither there. And then finally it will reach the global namespace, and x will be accessed from there. So global should be printed here, and here it is. And please keep in mind that this green color in center is just to protect these codes from merging into each other or running into each other. So I just kept the central code green to mark boundary. Otherwise there is no specific meaning of that color. Now let's come to classes. So this is first case. Here I am defining classes the way we have been doing this during this semester, and let's see how this rule works. Actually LEGB rule doesn't work here, and why I'm saying this, let me show this to you through this example. So here I am writing this code. I have defined this variable x in global namespace in the main program, and now I'm defining a class A. Here I'm defining a variable x is equals to class. So this x is actually a class variable belonging to this class A, right? and then I'm defining a method, and then I'm defining an instance variable inside this method, which is x, right? And why it is an instance variable? Because I'm accessing it through self.operator, and then I print this instance variable x. So let me instantiate an object of this class A, this small a, and then let me call this method. Now what should it print? It will access this method from class A, and there I have already defined an instance variable x, and that will be printed. So it should print inst, instance. Inst is for instance. So here it is. Okay, now in second code, what I am doing, this is exactly the same code. I'm just commenting out this statement. Now when this method will be called from class A, what will happen? This self.x, it cannot find any value for this, any instance value for this. So obviously it will initialize an instance variable x to that value that has been globally assigned. So here x should contain class, and this is what we saw in the initial examples in lecture 4 and 5, sorry, not 4 and 5, 5 and 6, etc. So it should print class. So here it is. And in the third variant, I am commenting out this second statement also. So two statements I have commented out, which are highlighted here in red. Now if I try to access x, according to LEGB rule, it should access the global variable, but that doesn't happen here. So this is what I meant by saying that LEGB rule does not apply to instance variables in a class. So if now I run this code, what will happen? It will produce an error that there is no variable x defined in class A. Now if this LEGB rule doesn't work for class variables and instance variable, then why we need to revisit this? Actually this LEGB rule still works for local variables, and if you can recall, local variables, these are the ones that are defined within the which are defined locally within the methods of a class. So let me show this to you through an example. So here I am defining this global variable called global, and then I'm defining a class A. Here I have a class variable known as again is the same name x, and I'm assigning it a value class. Then I'm defining a method, and now this time inside this method I'm not defining an instance variable, I'm defining a local variable x. And how can you identify that it's a local variable? Because I'm not using that self.operator with it. So let's print this x, and in main code I'm instantiating an object small a of this class A, and I'm calling this method. Now here it's really easy to guess method will be printed, because print x will access x from the local namespace of that method, and there x is equals to method, so method should be printed. Here it is. Okay, now in second variant the code is the same, but I have commented out this statement. Now some of you might be thinking that since I have commented out this x, then x of class A should be accessed, like class variable x should be accessed. But the problem here is that x doesn't lie within LEGB rule. So if this print statement, it does not find any x in the local space of method, it will go to the global namespace. So here global will be printed. So the point I want to highlight here is that this class variable, it doesn't come in this LEGB hierarchy. So if a method is if a variable is not found in the local namespace, then we'll go to enclosing namespace, which is not here because we are not using any nested functions. It will go to global namespace. So global will be printed in this case. Okay, let's see another example. In this example, I'm defining a global variable x and assigning it this string global. Then I am defining a function known as func, and in functions local namespace I am defining this x again and assigning it this value function. Now within this function I am defining this class A, and this is a class variable, and I'm assigning it this value class, and here is a method in this class. In this class I'm again assigning a local variable x, and I'm assigning it value method, and then I'm printing this value x, right? So let's instantiate an object of this class A within this function, and I'm calling this function, okay, and then calling this method, and then I'm calling this function from the main program. So when this function will be called, this class A will be defined, its instance will be instantiated, and then this method will be called. So when this method is called, it will try to print x, and this x will be fetched from the local namespace of this method called method, right? So method should be printed. Here it is. Now in this second variant, the code is the same. I have only highlighted this one statement. Sorry, I have only commented out this statement which is highlighted in red here. Now when print state x statement will be executed, which x will be fetched? I showed you in last example that this x, which is the class variable of class A, it will be skipped because it does not lie in that LEGB path. So this will be skipped, and I expect x is equals to function to be printed. So function should be printed at the output, and here it is. And in the third variant, I'm commenting out this statement where x is assigned to function. So this time, when print statement tries to find x, it will not find it in methods namespace. Class namespace will be skipped. It will not find x in functions namespace. So global x will be accessed. So it will print global. Okay. Here is an exercise for you. Here is some code, and here you have to determine the order in which x will be searched. Okay, so what you have to do, you'll find this code in that code file as well. So you just execute this code, or I would recommend that without executing, just try to figure out what it will print. So determine the output of this code, and then comment out that green highlighted statement, and then try to figure out the output again. And then you can of course run this code from that file, and you can compare your results with that. So that's all for today. Here's a quick recap. In today's lecture, we saw how we can differentiate association, aggregation, and composition while coding. It's just a matter of object instantiation, like where you instantiate it, that will categorize it as a composited object or an aggregated object. Okay, if you recall from other lectures that we did on multiple inheritance, initially what we did in phone book class, we first defined a list within a class, and then we rejected that approach because it was causing double indirection, and then we inherited from class list. So and then when we came to multiple inheritance, what we did, we came back to the former approach, like we started making some of the parents part of the class. So the point here is that when you are using inheritance or multiple inheritance, that makes your code look cleaner. Like you don't have to go for double indirection again and again. Access to methods becomes really simple. But the problem here is that if the class hierarchies, they are too complicated, that may result in some unexpected logical errors. So in order to avoid that, you can go for association. So what I want to highlight here is that it's a matter of choice. Like when you are designing a problem, you have to see the scenario and decide which approach should you go for, like multiple inheritance or association. Both have their own advantages and disadvantages. And lastly, we saw that LEGB rule does not apply to class and instance variable, but it does apply to local variables. Thank you.